All right, looking at parallel lines, what does that mean? Okay, so when you got parallel lines in geometry, then you can have all kinds of possibilities. So remember, parallel lines also have two arrows or one arrow in between them. So here's a parallel line. Okay? And we have an arrow like that. The distance between parallel lines, perpendicular distance between parallel lines, are equal throughout, like a railway track, right? Or borders. Parallel lines are everywhere in the world. If I combine this parallel line with another line, let's say connecting these two over here, okay? So we call this line a transversal. It crosses the line. So let's say I drew one that went right through somewhere, just randomly like that. That's your transversal. And I've got this coordinate over here, which is A, or let's say point of contact. I'm going to call that point A, and I'm going to call this point B. And when it comes to parallel lines, we have special qualities. You'll notice that this angle is an obtuse angle, and because it's parallel, it's equal to this angle over here, which is also obtuse. Obtuse meaning greater than 90, but less than 180 degrees. We call these two angles, we give it a special name. The angles are known as, particularly that part of it, is equal to, or known as, corresponding angles. I'm going to label each corner of this separately. So I'm going to call this A1, which is that part, the obtuse angle, A2, A3, and A4. B1, B2, B3, and B4. Looking at parallel lines like this, I can see that A1 is equal to B1 because they're corresponding angles. Let's discover what is corresponding angles first. We know it's angle A1, which is equal to angle B1. Because they're both in the bottom right-hand side of the intersection of the transversal and parallel line. And also A4 and B4 does the same thing. So A4 is equal to B4. Also parallel lines, according to that. And then A2 is equal to B2. Right, so B2, A2, they equal as well. Because they're in the top right-hand corner. Right. That's also going to be corresponding angle. B2 and B2. Then we got B3 and A3. A3 is equal to B3. Also corresponding angles on there. And those are all the different corresponding angles. We also note that this can be expressed as what is known as the F shape. Okay, so I can actually see some kind of F shape. And when you see the F shape, you'll actually start noticing, okay, well, if there's an F this way, then I'm going to have some corresponding angles over there, right? And I'm also going to have some corresponding angles over there. And if the F shape is going the other way, the F shape is going the other way, it still works. If the F shape goes this way, it still works. And so we still would have corresponding angles over there. And lastly over there as well, corresponding angles. So technically you can actually see that that's quite a nice picture of all the different types of corresponding angles. Okay. Let's look at the next thing now, which is going to be still parallel lines, but it's another type of angle, which is also equal when you have a transversal that's running through like this. Okay, this is still part of parallel lines. And I'm going to call this A1, 2, 3, and 4 still. I'm going to call this intersection B1, 2, 3, 4 as well. Parallel lines, all in order. The next one, these two angles are exactly the same if they're parallel lines. And they're both acute angles in this case. So when you have a transversal and you've got parallel lines, the angle, in this case A4, will be equal to angle B2. Let's write that down. A4 equals B2. Another two angles which are equal is A1 and B3. Obviously, if those two angles are the same, then A1 and B3 must also be the same because they both add up to 180 because they lie on a straight line. So A1 is also equal to B3. We call these angles a special name known as alternate angles. So we end up saying that those two are equal and those two are equal. Here we look for what is known as Z shape. Z shape, remember, can produce acute angles or they can produce obtuse angles. So you can see the dark blue line produced the acute angle and the light blue line obtuse angle for alternate angles. Okay, if I have to highlight it again, and once you remember this, once you start applying this in a few questions, you'll see how it goes. Those two angles are equal. Okay, alternate angles. Keeping with this same idea, we then have what is known as vertically opposite angles. Parallel line, same parallel line, transversal, 1, 2, 3, 4, 1, 2, 3, 4, A and B. We're now going to look at what is known as vertically opposite angles. The vertically opposite angles are equal. These are easily seen. They're simply across each other. The two lines meet like that. So that line and that line, basically, I mean that angle and that angle would be equal when these two lines cross. So A1 is equal to A3. A4 equals A2. Likewise, B1 equals B3. These are vertically opposite angles, and B4 equals B2. There you go, there. Everything else we did still holds true. And I specifically put dots and crosses over here because those two angles are also the same because of corresponding angles. So just to bring corresponding angles back, those are corresponding, those are corresponding, these two are corresponding, and those two are corresponding as well. And those two are also alternate, and those two are also alternate as well. We've got corresponding overlapping with alternate angles as well as vertically opposite angles over there. The next one is not equal angles, but it adds up to 180 degrees. And together on the inside, you will find that I'm saying basically this angle and that angle will add up to 180 degrees. Now both angles are on the inside, and we know those two are alternate as well and equal. So obviously that's going to be adding to 180 degrees as well. But these are on the inside, we're not dealing with the outside. So here I can state the following. Let me just not forget to put the parallel lines. If I don't see those two arrows, that means it's not parallel, which means that I've got to now be careful and say, okay, well, I can't assume that it's parallel unless I see those two arrows. These are known as co-interior, together on the inside. And these angles are not equal. They add to 180 degrees. So A1 and B2, A4 and B3, all right, I just said it doesn't add, and I just said it adds to 180 and I put it as equal. A1 plus B2 equals 180 degrees. And A4 plus B3 equals 180 degrees, and that's how you write those two angles over there. Okay, so it'll be that angle, and that one, this one, and that one, and they add up to 180 degrees. Co-interior angles. A few of the old rules that we have, if you have all angles that are meeting at a central point, we call it angles around a point, right? So if I got a, some kind of rectangle over here as well, we know that means 90 degrees. If I make this x, and I make this 1.5x, and I make this 2x, I know that angles around a point add up to 180 degrees. All right, then you must be wondering now why if I brought this in with parallel lines. Just to go back, those angles add up to 180 degrees. Those angles add up to 180 degrees. Those add up to 180. Those add up to 180, etc. So you can always, 360. Did I say 180? 360, 360, 360, 360 as well. All right, it's a revolution. 360 degrees. 180 is always, remember, on a straight line. Just to correct myself there, 180 is always on a straight line. And there are plenty of straight lines where you can actually see that. All right, those are the main rules around parallel lines. Looking at the next part now, this one over here, we've got angles around a point. All right, we can't go through this